Firefighters arrive at a burning electric car and start pouring water on it, thousands of liters. And here is the strange part. That water is not putting the fire out. It was never going to. It is not even trying to. Because the thing burning inside that car has quietly broken the one rule that every other fire you have ever met obeys. Start with the fire you already understand. Every fire you have ever put out was the same fire, and it stood on 3 legs: something to burn, heat to get it going, and oxygen, borrowed from the air in the room. Pull any one of those legs and the whole thing falls over. That is all a fire blanket is doing. That is all a lid on a frying pan is doing. That is all the red extinguisher on the office wall is doing. None of them are clever. Every single one of them is just taking away the air.
Now, open up the battery in your phone. Inside is a sandwich, rolled up like a Swiss roll. One layer that hands out lithium, one layer that catches it, and between them a plastic separator so thin it would take about 100 of them to match a sheet of paper, keeping the 2 sides from ever touching. And the whole roll is soaking in a liquid called the electrolyte. Remember that liquid. It is flammable, and it is the fuel in this story.
Now let that cell get too hot. Maybe it got crushed in a bag. Maybe it was charged overnight by a cheap charger that did not know when to stop. Maybe it simply carried a microscopic metal flake from the day it was built. It does not matter which. Somewhere around 80 degrees Celsius, a protective film inside the cell starts to break down. And that breaking down gives off heat, which pushes the temperature up, which breaks down more film. Congratulations, you have just built a staircase that climbs itself. At around 130 degrees, that wafer of a separator melts. The 2 layers it was holding apart finally touch, and a battery touching itself is a dead short, dumping everything it has been storing directly into heat all at once. The staircase is now taking the steps 3 at a time. Engineers have a name for this. They call it thermal runaway. And this is the point where the cell stops being a battery and starts being an event. And then, somewhere past 200 degrees, the thing happens that changes the entire situation. The positive side of the cell is not a lump of metal. It is a crystal, a neat lattice built out of metal atoms and oxygen atoms, stacked in tidy layers. Heat it far enough, and that lattice comes apart. And when it does, it lets its oxygen go inside the cell into a sealed metal can that is already full of hot, flammable liquid. Read that again, because it is the whole video. The fire is not borrowing oxygen from the room anymore. The fire is making its own. You could pump every last molecule of air out of that building, and it would carry on burning, perfectly content, because it stopped needing you about 100 degrees ago. So it is not a campfire anymore. It is a marine flare, the kind that keeps burning while you hold it under the water, because it carries its own oxygen with it and genuinely does not care what is going on around it. Throw a blanket over a flare and it will burn a hole straight through the blanket and keep going. That is the object sitting under the floor of that car, and there are hundreds of them. Which leaves whoever is holding the hose with exactly 1 leg of that triangle still standing. Not the fuel, that is sealed inside the can. Not the oxygen, that is being manufactured on the premises. Only heat. So they stop trying to put the fire out, because there is no putting it out. And they do the only thing physics has left on the table. They cool it. And that reframes the entire scene you are looking at. A car battery is not 1 cell. It is hundreds of them, packed shoulder to shoulder in a tray. 1 cell in Runaway is a blowtorch pointed at its neighbors. And if a neighbor gets hot enough, it climbs the same staircase. And so does the next one. So the water is not aimed at the flames at all. It is aimed at the cells that have not caught yet.
This is not firefighting. It is a race, and the water is trying to reach the next cell before the heat does. Which is also why the advice everybody repeats is precisely backwards. Never put water on a lithium fire, people say. It will explode. That is true, and it is true of lithium metal, the shiny, soft stuff that skitters and fizzes across the water in a chemistry class. Your phone does not contain that. A lithium-ion cell holds barely any metallic lithium at all, and the standard advice for one loose overheating battery is to drop it in a bucket of water. The fire brigade is not being reckless. They picked water because of everything on the truck. It is the best at stealing heat. And now, every strange detail about these fires clicks into place. Why one burning electric car can swallow something close to 30,000 gallons of water, when a petrol car takes a few hundred. Why the flames die down and then come back an hour later, or the next morning. Because a gas extinguisher kills a flame beautifully and removes almost no heat. So all you have really done is switch the lights off on something that is still glowing inside. And why a damaged pack gets towed into the open, parked far away from anything that matters, and watched, sometimes for 3 whole days. So the next time you see that footage, you will know what you are actually watching. Nobody out there is putting that fire out. There is no putting it out. There is a chemical avalanche inside a metal box that turned up with its own fuel and its own oxygen, and a group of people with a hose doing the only thing that still works, stealing its heat one cell at a time until the avalanche runs out of things to knock over. If you like the feeling of the world getting a little less mysterious, subscribe. One complex idea made simple every week.